Hello, welcome back to the second part of week 7 of ECE 9013 course. In this part, we're going to discuss procedural attributes, or what we call methods, and clarify how we can define our own print method. So what is a method? A method, or what we also call as a procedural attribute, is basically a function that only works with this class. So Python allows and always passes the object as the first argument. The convention is to use the self keyword as the name of the first argument of all methods. And then the dot operator is used to access the attribute. The attribute can be a data attribute of an object or a procedural attribute, which we also call a method, of an object. So for example, if we want to define a method for the coordinate class, here we already defined that we're creating a new class called coordinate. Then we defined the initialize method, which defines the data attributes x and y. Then we define a procedural attribute, or a method in this case, called distance, that's applied to self, which is used to refer to any instance of that particular class type. And here the keyword other represents another parameter that's given to the method, which also belongs or is an instance of the same class. We define the difference in the x direction to be the self.x minus other.x raised to the power 2. And here we use the dot notation to be able to access the attribute as mentioned earlier. Then we define also the value for in the y direction. So self.y minus other.y raised to the power 2. And then we are returning the square root of that sum. So basically, other than self and the dot notation, methods behave just like any functions. They take parameters, they do operations, and have a return for that method. Now, to use a method, we can use it as part of the class, which is the conventional way. So for example, here if we define the core or the instance variable c as coordinate 3, 4, and then 0 to be the coordinate 0, 0, we can print out the distance method that we're calling from 0. So this is the object to call the method on, that we're applying the method on. We're calling the distance method and we're taking it from the variable or parameter 0. This is also equivalent to using the coordinate class. So we use the name of the class, name of the method, and the two parameters that we're trying to use. So both of these can be applied and they're both valid. This is obviously the more intuitive way of calling the method on a particular instance of a class. Now, another important method is how to define our own print method or a print representation of an object. So here if we want or if we define the instance C of class coordinate and we call or invoke the function print C, what do we get? This usually is an uninformative print representation by default. So we need to define a new method, what we call _str_ method for the class. This is the method that Python calls when we use the print on the class object. So we can choose what it does. So for example, when we print a coordinate object, we want to show the actual x value and y value. To do so, this is how we do it. So here again, we have the class definition with the name, the way to initialize it. We defined the distance method, and we define the _str_ method, which controls what is printed out when we invoke the print method on an instance of that class. So here we're returning a string composed of the character less than, just so that we put them between these two characters. Then we are adding or concatenating to that a string version of the value of self.x, so basically returning the x coordinate. We concatenate the comma and then another concatenation of a string version of the y value. So now if we use this or invoke this command print c based on the definition of the str method, this is the output that we would get on the screen. So, for example, in this case, we can ask for the type of an object instance. So here, for this variable c, if we invoke the command print c, we get the value of 3 and 4, because these are the x and y value. So in this case, it would return the _str_ method. Or we can print the type of c, which will give us that this is of a type coordinate. So the type of the object c is a class coordinate. So again, in this case, if we click or if we write the command print coordinate, we would get the same thing, because coordinate is a class and its type is object, which will give us type. One important method to be aware of is the isInstance, and this is used to check if the object is a coordinate object. So for example, here if we print the result of isInstance c coordinate, it will give us true, because c, the type of c is coordinate. Other special operators include, for example, the addition, subtraction, equal, which is checking if there's anything, if the equality greater than, less than, the length, print, and many others. Like print, we can override these to work with our class. So for example, we can define them as usual with a _add self-other, and this, for example, would add the two values. Subtract would calculate the difference between them. _eq to check for equality. Less than or LT, length, print, and others. So as an exercise, you can try to create a new type to represent a number as a fraction. The internal representation is basically two integers, the numerator and the denominator. The interfaces or the methods, which is how we interact with the object, we need to define the add and subtract methods, the print representation and how to convert to a float, and inverting the fraction. Note that this is just an exercise for you to practice. So, as a conclusion for this part, implementing a new class or implementing a new object type with a class, we need to define the class, define its data attributes, which is the characteristics of what is the object, and define the methods, which are the procedural attributes, which represent how we can use that object. Now, to use this new object type in code, we can create instances of the object type and do operations with them. So this is a comparison between the class definition of an object type and an instance of a class. The class name is the type. It's generally defined using the self keyword to refer to some instance when defining the class. This keyword self is a parameter to the methods that we define within the class definition. The class can define data and methods which are common across all instances. However, an instance is just one specific object of that class type. So here, for example, C1 and C2, both of them are instances of the class coordinate, but they are different instances. They have different data attribute values because they are different objects. So the instance has the structure of the class, but with different values. Thank you.